Um, who's my favorite student? Well, it's good old Anne. I noticed last week that a lot of students were asking me questions about lesson one, number one. In other words, I sensed a trend that a bunch of people hadn't started doing any of the homework. You want to break that trend. Let me summarize what we've done so far. We've said if you're moving in a circle, you can calculate your centripetal speed by going 2 pi r over the period, where t is how long it takes to go around once. Oh, got a latecomer coming in. Got to pause the video for just a second. Then we also said there are ways to find acceleration. One way is v squared over r, and another way to find circular acceleration is 4 pi squared r over t squared. The most common dumb mistake, Nuji, notice both of these are accelerations. F equals what? If you're doing a force, don't forget to put an m in front. But it's the most common time is they forget to put the m in front of this one because it looks so complicated. I already had two kids last block. Why am I getting the wrong answer? Because you found the acceleration, not the force. Oh, yeah. Number one then says this. An airplane turns a complete horizontal circle in 2 minutes. Well, first thing I did was, nice try, Mr. Dueck. But I also said, that's the period. That's how long it takes to go around once. If the plane's speed is 170 meters per second, I started out thinking to myself, I don't think I'm going to solve this in terms of acceleration. I think I can solve this using the speed equation. Yes, I can. I can get the radius by itself. Stuff moves diagonally. It's going to be times by t, divide by 2 pi. It's going to be 170 times 120 divided by 2 pi. It's going to be 170 times 120 divided by 2 pi. And I got 3,200. I rounded to 50. I went to 3 sig figs, which at first seemed a little big. And then I went, actually, no, that probably makes sense because that's 3.25 kilometers. That's probably the radius of a circle that a plane would do if it was making a big circle. I'm okay with that. B said, what's the centripetal acceleration? I can find it two ways. I can use v squared over r, and I can use 4 pi squared r over t squared. Mr. Dueck, I thought you said you had to multiply by m. No, that's for a force. This wants an acceleration. I looked at both of those and I said, you know what? I'm using my answer from part A no matter what. So I chose to go v squared over r. I went 170 squared divided by, and I used my answer button. 8.9, is that right? So actually, this pilot is feeling a little bit less than 1G. This pilot would be feeling a little bit lighter, tiny bit. In terms of part marks for number one, I would give you a half mark for that. For A, a half mark for that, half mark for that, and a half mark for the answer. But if you got it right, I'd give you 2 out of 2. Here, I'd give you 1 mark for that, half mark for that, and a half mark for the answer. And if you use the 4 pi squared r over t squared, you would get the same answer as well. Yes? Thank you. Squared. Oh, you candy. Number 2, what centripetal force? What force? Centripetal. What force? Centripetal. No free body diagram here. This is going to be straight F equals ma. Oh, C. Which version? They gave me the period, so I'm going to use m, don't forget the m, 4 pi squared r over t squared. It's going to be 12 times 4 pi squared r over t squared. It's going to be 12 times 4 pi squared times r divided by t squared. I got a really big answer. I got 71,000. If I go to 3 sig fig, 71,100 newtons. And at first I was a little nervous by that, but then I went, wait. Presley, in this question, what's the mass? Bowling ball, roughly. What's the radius? You and I are about 6 meters apart, maybe even a bit less. What's the period? That means point 0.2. That's 5 times per second. We're whipping a bowling ball at the end of a 6 meter string around our head 5 times a second. That's going to take a lot of force because that bowling ball would be a blur. If it hit you, it would kill you instantly. Yeah, okay, I'm okay with a big answer. I was nervous at first, and then I zoomed out, kind of looked at the numbers, and I said, oh, yeah, it would take a huge force to do that. Now, I don't know why I made this one worth 3 marks. I need to change that, but I guess it's going to be, I don't know, 1 mark, 1 mark, half mark, half mark. Number 3, now they want the centripetal acceleration. AC equals, you know what? They gave me the speed, so I'm going to use v squared over r. It's going to be 5 squared divided by, and I said 25 centimeters, that's 0.25 meters. This one works out even to 100, does it not? No, yeah? Yeah. One mark, half mark, half mark. Ooh, now I'm getting into free body diagram territory. Okay. Ferris wheel. In fact, I noticed we're at the top of the Ferris wheel. I did a quick sketch. I did that. And I said, okay, what are the forces acting on this person? Get the obvious one. I definitely have gravity down. What else? There's going to be a normal force. Which way? On a Ferris wheel, it's always the direction your head is pointing. In fact, on any ride, it's the direction your head is pointing. And yeah, Joseph, I agree. It's going to be up. Why did I draw the normal force smaller? What path are we tracing out? A circle. Where is the winning bigger force going to be pointing? Toward the center. So I'm going to get this. mg minus fn equals m, you know what? They gave me the period, 4 pi squared r over t squared. They want me to find the normal force. So, Caden, I did a quick swappy dance to get the Fn by itself. And when I did that, I ended up with mg minus m 4 pi squared r over t squared. That equals, and I put the normal force on the left because that's where I like to see it by itself. I did a quick check. Ooh, do I know the mass? No. What did they give me instead of the mass? Starts with letter W. No, now. They gave me what? Weight. No, now. I'm sorry, I can never resist that joke. If I know the weight, how can I figure out the mass in kilograms? Yeah, weight is mg, so divide by 9.8. I think when I went mass equals 637 divided by 9.8, was it 65? I think it worked out evenly, yeah? Yeah. Okay, so now I've got that. No, let's plug in the numbers. So I said the normal force is going to be, I started to go 65 times 9.8, and then I said, wait a minute, it's just going to be 637 minus 65 times 4 pi squared 9 all over 25 squared. It's going to be 630, clear, 637 minus 65 times 4 pi squared r divided by 25 squared. Did y'all get pretty much exactly 600? Not quite, but close. If you got that 3 out of 3, otherwise 1, 2, 3, 4, 5 things, I would probably go something like this. 1 mark for that, half mark if I saw the mass, half mark for that, half mark for that, half mark for the answer. What's the force at the bottom? Again, I did, Chantal, a quick sketch. I said, what are the forces acting on it? Gravity down and normal force. Why did I draw the normal force bigger this time when I didn't draw the normal force bigger? Well, what path are we tracing out? A circle. So where's the bigger force going to be pointing? Toward the middle, which in this case is upwards. So I said, okay, I can do this. It's going to be normal force minus mg equals m 4 pi squared r over t squared. I said to get the normal force by itself, I would just plus mg over. So I said it's going to be mg. You know what? Yeah, I smiled here and I went, wait a minute. Well, I wrote mg plus m for pi squared r over t squared. Then I said, I'm going to be lazy. Copy. I said it's exactly the same thing, except what am I going to change? Yeah, I'm going to change the minus to a plus. I said I can do that, easy peasy. There. In fact, I said, you know what? I'm going to be lazy on my calculator as well. I think I can just backspace and change the minus sign to is it 474? Sorry, 674? Is that right? That was nice. Newtons. Similar marking scheme as before, except I don't have an extra half mark, so I went 1 mark for that, 1 mark for that, half mark, half mark. Ooh, roller coaster loops. Key difference in roller coaster loop. At the bottom, the free body diagram for a roller coaster loop and a Ferris wheel will look identical. They won't look identical at the top. And I notice here, we're at the top. It says, it wants me to figure out how fast. You know what? This is going to be a job for a free body diagram. I'm going to have gravity down. I'm also going to have normal force down. Who's winning? They both are. It's a tie. It's going to be mg plus normal force equals m. Oh, how fast? They asked for speed. So it's going to be a v squared over r. I don't know the normal force. Oh, yes, I do. It's going to be mg plus 4.5 mg's equals mv squared over r. You could cancel the m's out here. I waited one line because I said 1 mg plus 4.5 mg's. I said this is going to be 5.5 mg's. That equals mv squared over r. Ooh, now the mass cancels. And I'm going to get the v by itself. Oh, hello, my old friend. I get the square root of GR. Oh, and a 5.5, but that's usually a clue that I've done it right if I get the square root of GR when I'm looking for a speed. So it's going to be v equals the square root of 5.5 times 9.8. What was the radius? Anyone, what was the radius? 9? 11. Thank you. Square root of 5.5 times 9.8 times 11, close bracket. Did y'all get 24.3 meters per second? Now, on a Ferris wheel, because you're attached to a rigid circle, a rigid loop, that would be your speed all the way through. In a roller coaster, you're going slower at the top, you'll speed up at the bottom. If I did ask you a part B speed at the bottom, you would expect to find an answer bigger than 24.3. Okay? In other words, if I was contriving these numbers and I want to make them at least somewhat realistic, I would make sure you didn't get an answer less than 24.3 at the bottom, because that would go, wait a minute, why did I slow down at the bottom of the roller coaster? I know enough of you have been on roller coasters, you would catch that. B, oh, now they want the radius. I said B, we're still at the top, so it's actually the same free body diagram. I didn't bother redrawing it. In fact, I jumped straight to the same equation. I said it's going to be mg plus f n equals m v squared over r. I had somebody ask, Mr. Dueck, what if I wanted to get the v by itself right now without doing anything else? I said, okay, it's a bit yucky, but what you would do is the mg plus fn would drop down like a domino. You would divide by m. If you just did that, times by r, that's wrong. What you would need to realize is you're multiplying everything by r, and now you could square root that whole mess. That would do it. If There was nothing else you could do to simplify, Joe, than that would get the V by itself. But there's more. They told us that the normal force is twice the weight, so I can rewrite this as mg plus twice mg equals mv squared over r. In fact, I can write this as 3 mg's equals mv squared over r. And the masses cancel. We're trying to get the r by itself. I guess r is going to be v squared over 3g. Is that correct? It says v is 16 divided by 3 times 9.8. V squared, Mr. Dueck. Don't forget the squared. 16 squared divided by bracket 3 times 9.8, close bracket. Y'all get 8.71 if I round off to 3 sig figs? Yes, is that right? And that would be meters. In terms of part marks for part A, I would probably 4 out of 4 if you got the right answer. Otherwise, 1, 2, 3, 4, 5. Really, I'd probably go 1 mark, half mark, half mark, half mark, half mark. Is that 4? That's 3. So I'd probably go like this. Half mark for the numbers, 1 mark for the answer. Here, I'd probably go 1 mark, 1 mark, 1 mark, half mark, half mark. I don't know. Can you give yourself a clear score, please, out of 23? If you need to lawyer with me, now is the time.